Good afternoon. We'll start with a class now. In our last class, we had discussed about our network lecture, and we started with a trial video. Now we'll start as usual with our classes. In our last classes, we are discussing on the protocols. Now, I given a definition of a protocols. Then, what do you mean by a protocol? The protocol will work in two ways. That is the peer-to-peer service it will give and a interface service it will give. In a last class when we are discussing and we had discussed that whatever layers will be there, the layer will do its own different task and it will do its own different function. But two layers are interdependent. Now the interface between these two layers will be done with a protocol. And then the peer-to-peer means other side system whatever is there. If this layer wants to communicate with that layer, then that is called as a peer-to-peer protocol. If you take a protocol as an object, this protocol will have two interfaces. One is to show this service interface, and another one is peer-to-peer interface. Now, first we'll come to what is service interface. Service interface, if we consider like this, if layer 1 is there and layer 2 is there, layer 1 will do its own function, it will have its own function, and layer 2 will have its own function. But the layer 1, whenever it's working, these two layers will be connected with an interfaces like this. That means the whatever service of this layer 1 is there will be transferred to the layer 2. Based on the service of this layer 1, this layer 2 will do its function. Now this particular part we call it as a service interface. Now coming to this particular service interface, whatever things is it, for example, we'll go with an examples now. For example, we'll consider like this, the one particular layer, for example, we'll consider this as an HOD, right? And we'll consider this as an lecturer or an staff or an faculty. So faculty if we consider. Now HOD will give some instructions to the lecturers that you have to do this particular task. For example, you have to give an assignments in your subjects based on this particular thing, and you have to complete these assignments within this particular day. Now there will be an interface, means one medium should be there or one interface should be there which will communicate between this particular HOD and this particular layer. Now this will be there in one particular system that we may call in our terms this as a department. Now coming to the other way, that is a peer-to-peer interface. What do you mean by this peer-to-peer interface? When we comes to peer-to-peer interface, the same layer will discuss, means will have a link with other layers or other system layers. What do you mean by this? The same layer 1, I'll consider other system. Here also layer 1 is there, assume, and here layer 2 is there. Right? And thus the interface between these two layers, this peer to peer layer, we'll call it as. Why we need that part? The working nature of our HODs will be a one protocol. That means how a HOD should work. Whatever instructions given from a higher layer for an HOD, that should be followed. All HODs, for example, assume that the principal sir will ask for one particular data that we need a student papers published in a year 2019 and 2020. These instructions will be given to the HODs. Now what all the HODs will do, all the HODs has to do the same work what the one particular HOD will do. Then this HOD will call the lecturers and ask that, so how many of your students has written a paper on their particular projects. So coming to this particular thing, here HOD and lecturer will become the service interface of one particular system, and the same work what other layer means other HOD will also do. He will communicate with lecturers and will collect data and it will goes to the higher authorities. Now this is a one peer-to-peer communication. Now we'll come to the other example also. We'll take which we will make. I want to make you much understand on this particular terms. Now coming to this particular thing, for example, we'll take a postman, right? So yesterday we had discussed it about on a postal service also. Now we will take this postman example. The postman of this particular side, that means the postman has to do the duty. What the postman duty will be there? He has to collect the letters from the postal box, whatever is there in one particular area, and all the letters he has to collect, and he has to submit that letter in a post office, right? And he will do other work in other side. If he comes to the destination side, he will do in the other work. What the other work he will do? He will take all the letters of that particular area from the post office and he will distribute that to the different houses of that particular area. So this is called as a layer-to-layer communication or a peer-to-peer communication. So this as a receiver, what the postman has to do, as a sender, what postman has to do. This we'll call it as a protocol. Now coming to this in depth of this particular protocol, how the things will work. Just 1 minute. Yeah. Yeah. Now, we'll come to the next particular thing, that is a protocol graph and a protocol structures, how a protocol will work in its particular types. Coming to the next important concept of this particular thing, that is the encapsulation. What is the encapsulation? Thus you have to make a note. And right here, encapsulation. The protocol, when it will do its own work, I'll repeat. Say in the last class we have did like this. There will be an application program will be there, and a process to process will be there, and a host will be there, and afterwards a hardware will be there. So this we had discussed in a each and every layer will have its own protocol. What actually this particular protocol means? For example, I will take the one thing. So whatever application data is there, the bulk information or on a messages of this particular information will be transformed to this process, where I told you in the last class that it will be divided into the parts like a packets. It will be divided into the unique packets. Now this particular process, how this particular process should work? Each packet it will take and it will put its own encapsulation or on a seal, which you can take into the consideration. Here process is always meant with two things, that is between source to the destination. That is, if as I told you in the last class that there are 100 packets to move from source to destination, what the process layer will do? Whether all the 100 packets are moving from source to destination in a sequence, it has to check, correct? No. Now coming to this particular thing, here while moving out all the 100 packets, it will think whether this moved in a sequence whether all packets are going or not. Now other side, another system, whatever will be there, the process layer, it will collect all the packets. If some packet is missing, it has to give information to this process layer that the information is missing. Here, one important thing is like this, how the things will be identified by the layer. That means how a packet will be identified, that yes, this particular packet is coming in this particular sequence only, and for this particular message stream only this packet is coming. How to identify that? So because of that particular reason, a header will be encapsulated on the packet. If data is there like this, to this particular data, the process layer, whatever will be there, it will put its details, that will call it as a header. Right? Now, that is a one important thing. Assume this is the data, right? For this particular data, process layer will put its header. Afterwards, what happens? The packet will be sent to the host layers. As we discussed yesterday, that here destination is not a necessary thing. That means in a host-to-host communication, which is my next system, that is very much important rather than a destination. Now, according to the route which has been there in a routing table, which is my next system, is that system is connected or not? So what happens now? Which is my next system? Whatever this data is there, it will be covered again. It will be covered again with another header like this. It will be covered. A host header will be there. It is encapsulated. This is encapsulation. The entire of this, whatever now will be treated as a payload. Now this header of a process layer is encapsulated in this particular host. For example, I will tell you, this host address, whatever is there, it will go to the next system. Yes, the packet has been sent to me only, which is a next node to send. I am not a destination, so which is a next node to send. All that routing details, everything will be there in a host. It never bothers about a data here. Getting? So once if the packet has been reached to the destination, there the host of that destination, that destination will think, yes, myself, this particular packet is there. Then it will tear that particular encapsulated seal, and then what happens? This, whatever the payload is there, it will be sent to the process layer or an above layer. There, this header will be taken into the consideration by the destination process layer. This is very much important. There, what information will be there? What is the sequence of this particular packet? And either this is an acknowledgement packet, either this is a data packet, all the details will be there. Which particular process this packet belongs to, this header will have a different information comparative to this particular. Then what happens? They will take out, means that details will be taken out, and that packet, whatever will be there, will be sent according to the application. So in this way, the encapsulation plays a very much important role in this particular terms. Encapsulation means covering data with its own header. So this is called as an encapsulation. Okay, we'll go with the next session with other terms. Thank you.